NURBS are mathematical representations that can very precisely model any shape from a simple 2D line, circle, or arc to the most complex 3D freeform organic surface or solid. But let's have a look into how can we build those geometries in Grasshopper. You can find the curves under the curves tab, and here you will find different ways of how to create them. For example, you can choose primitive, or by a little bit more complex ones by spline. You can create a line by just using 2 points. So you select the start point and the end point, giving you as an output a line segment. You can also create circles from the primitive tabs. So here you can find it. A circle is it's created by a plane, a base plane that could also be a point. So if you don't give this plane at the very beginning, it will just give you the wall XY 00 as a default, but you can also change that one. Right click on the component, set one plane, and choose any other location. So we press Shift to keep the coordinates straight, and now the origin of this circle have changed. Let's jump into ellipse. So here happens the same. So you can choose the plane where the origin of this ellipse is gonna be, and then you can just set a slider with a different range, and then you can very easily change the dimension of your ellipse. Something similar happens to arc, but the difference is that while this is asking for a plane and a radius as before, here is also asking for a specific angle. So the angle by default is given in radians, as you can see here. But if you want to have the control in degrees, you will need to find this component that is a radians component. So with this component, it will just translate degrees into radians. More sophisticated curve types are under curve spline, and that's what we will be exploring in this video. So here I have just selected a couple of them. We can set different points in different lists, change the ones I had before. So we have set 5 points. Then it's also asking for a degree. At the moment it's 1, so that's why we have straight lines. But look what's happened when we change the degree to 2. So the degree is basically how relaxed or uptight your curve is. So if we go to degree 3, you see that your curve is much smoother than before. There is a third input parameter that is not so important, but it's just if you want to turn your curve into periodic, you can find this component by typing toggle, Boolean toggle, and it's just asking for a true or false. So let's see what's happened if we turn it to true. So it's just closing the curve. Interpolate is quite similar to NURBS curve, but the difference is that the curve is passing through the points. And finally, the polyline, as before in the interpolate component, the curve is passing through the points, but in this case it's just made out of straight lines. So there are different ways how you can analyze geometries and curves in Grasshopper. So if we turn on this, you can see that I have a curve. It's giving us the start point and the end point of the curve. So those we can just select them individually. Another very important component to analyze curves, this is the evaluate curve. We can always evaluate a curve at a specific parameter. So that means that inside this curve, we can choose where to place a point inside this geometry. So with a number slider, we can move this along the curve, and it will always stay inside the curve. So here I really want to stop and explain two very important concepts. This is the domain of a curve and the length of a curve. So the domain of a curve is not the same as the length. As you can see, we have a curve, and the domain, it goes from 0 to 100 something, but the length is 59,79. This is very important because at the moment of evaluating the position of this point on the curve, it can happen that we have a different. And now you can see that if we move from 0 to 50, we are moving on the domain that is about until the half. But you can also see that it's actually not really the half of the curve. For this, we need to reparameterize the curve. As you can see, after reparameterizing, the domain has changed from 0 to 1. So it means that our component now it's turned into orange because the parameter that we are giving is at the moment is 22. Is outside of the curve domain. So it means that we need to bring this down until something in between 0 and 1. So we can very easily change this, and we can also give floating points. So to have decimal, we decrease also the accuracy to 2 decimals. Press OK. And now we see that we can move very precisely from 0 at the start of the curve to 1. And we are going to use this a lot in this course. Display, for example, the control points of a curve. You can as well find this control point component under Analysis tab. So here you see that the control points are now selected. And to finish with this chapter, I just want to also look into different ways how to display information in Grasshopper using analysis components. We will be able to get as an output the point on the curve at the parameter t, as we saw before, and the curvature of the circle at t. So if we move our slider, we will see that we get as an output the circle at this specific point. We can also display the curvature as a graph, and this is good when you want to check the continuity of specific curves. So here is asking just for a curve. We can use the previous one. Is asking you for a density that we can change the density and the scale. Let's continue with the surfaces in Grasshopper, and we will have a look to the different types of surfaces that can be generated, such as primitive, freeform, and afterwards we can also analyze the different surfaces created. Here we have a cone, we also have cylinder, a sphere, a box, or a plane surface. Let's continue with freeform surfaces. So here you can see a lot of different possibilities. So I have just chosen a few of them. For example, under the edge surface, that is in freeform edge surface, here is basically a component that creates a surface from 2, 3, or 4 different edge curves. So we just need to give this curve by linking the curve parameter into what was drawn in Rhino. So we can select the third and now right click, select one curve and the last one, and we can preview the result. So here we have a surface. What is our boundary condition for the curve input? But actually this makes sense because if we, for example, connect the corners of our curves, we will see that it will perfectly match to the boundary condition. But what's happened is at the moment where we have open curves, it will interpolate in between the end points. So here we see if we create a line from this start point to the end of this point, so it's just taking the midpoint as a reference. We can also create surfaces by giving a straightforward boundary condition, and this is, for example, a rectangle. Important, it needs to be planar. If we continue with the different freeform possibilities to build surfaces in Grasshopper, we will find another component that is used a lot. This is the loft. So we saw that also during the Rhino session. So here we need to give a bunch of curves like we have here. I already internalized this information, so we see that there are two planar curves in one single component, and the loft will just generate the surface. You can have a look that there are two inputs values, so one is selection curves and the other one is option. For the option, you can directly type on the search keyword loft options here. And this is exactly this component where we will be just able to decide about certain details about the surface generation. And finally, another very important component that is actually like a translation one-to-one to what is possible in Rhino. This is the extrude component, and this is gonna give us the possibility to extrude surfaces. So if we preview, we will see that this extrusion worked perfectly and is extruding the surface in Z direction. We can choose the direction that we want, so if we decide to go to Y, we can choose a different unit vector, and then we see that the direction of extrusion changes. And to close this chapter of surfaces, have a look into what is the analysis. And this is one of the most important tabs where you will find a lot of very useful components. For example, if we just draw a surface that can be just linked directly from Rhino, or it can be generated in Grasshopper, we can subdivide the surface in many different ways. For example, we just give this surface as an input, and then we give the segments U and V. There is a given value that is 10 by default. We can have different densities in different UV directions, or we can keep both with the same proportion. So what is very important to know is that all this information that we are getting afterwards is points as tree. So we are gonna have a look a bit later. What is a tree? All the normals, so those are each of the vector and the UV parameters. So we can just come here and say, I just wanna select the point, but have a look that now this wire changed. So this means this is a list of lists. We can display this vector here. So we can just give a vector that's vector to preview. We can give the anchor point, and those are each of the vector. We can see that we have all the vectors pointing down. But check that all the vectors are pointing down, and that means that surfaces has also a direction. So it has a face, main face, and a back face. So this can be, of course, flipped. So you can flip a surface and now you see that the vectors are changing in direction. Evaluate the surface. What does it mean, evaluate? So here we are gonna be able to define a point at a very specific location. So with this MD slider, and you can set the domain. So right now it's from 0 to 1, and this is exactly what we want, since as you can see, we have a reparameterized surface. So we are moving always in the domain from 0. 0 is here, 0, 0, and 1, 1 is on the other corner. And this is a very interesting component, since it's giving us a lot of information. So it's giving us the coordinate of this point, is giving us also the normal vector of this point, and also the U and V value inside of the surface. It's also returning a frame, and this is actually very interesting because that means that we can orient later on objects using this surface. As you can see, the plane is rotating along the surface and adjusting to the tangent of this point at that specific location.